Hello students, how are you? We have question 90. The question says two identical resistors X and Y, both of them of 6 ohm, okay? They are connected in the opposite circuit. They say that the electromotive force of the battery is 12 volt and the internal resistance is 2 ohm. The question is, what is the reading of the ammeter? I have this ammeter, they need the reading. It means I need the current in this part of the circuit, of course when the switch is closed. I need the current in this part of the circuit. This is the meaning of the question. The reading of the ammeter. Okay, I need the current. Okay, let me erase this line. Of course, we know that this is Kirchhoff's problem, okay? Because I have a circuit with 2 loops, okay? So let's discuss the circuit before we start solving. Here I have the battery. This is the battery, okay? The current goes out of the positive. It goes from here. Let's call it I1, okay? This current, when it reaches this junction, it will be separated into here. I'll call it I2, and down here, I'll call it I3. Okay, so I3 is the current that goes into the ammeter. So basically, I am looking for I3. Okay? We agreed on this? Okay. Now, if we apply Kirchhoff's first law on this junction right here, okay, we can say that I1 equals to I2 plus I3, okay? This is the first equation that I got, okay? Now, let's apply Kirchhoff's second law on the loops. I have here, up here, the upper loop in here, and here the lower loop. Okay, so let's apply Kirchhoff's second law. I will choose a direction to move, as you know from Kirchhoff's second law. Okay, I will draw the direction here. I will go clockwise. I will go clockwise. Okay? So, let's apply Kirchhoff's second law up. I start with the electromotive force. Okay? The electromotive force. Okay? Notice that the direction I chose is going out of the positive. Okay? Which means that the electromotive force is positive. Okay, so it's going to be 12. Okay? There is only this battery, right? Now, I have this resistance. What current goes into it? It's the I2. So I say, pay attention that the I2 actually agrees with my direction. The I2, here, let me erase this one. The I2 here agrees with the direction I have. It means it is original, so it is minus 6 I2. Minus 6 I2. Okay? This is the I2 here. Okay? Okay. What else? Minus. Of course, I wrote the minus because I solved it before. Now, notice I have an internal resistance. If we want, we can draw it right here. This is the internal resistance. What current goes into the internal resistance? It's actually I1, and I1 agrees with the direction that I chose, so it is minus 2 I1. Okay? Now I don't have any more resistors or any more batteries, so it equals to 0. This is equation 2. By the way, I will make sure that I'll make a video about how to apply these things in details, inshallah, okay? Don't worry. I'm talking about Kirchhoff's second law, mainly. Okay? Now we will go to the lower loop. Let me erase some things here. Okay? In the lower loop, I'm gonna choose a color. Let me take, well, the black. Okay. In here, I will choose a direction. In the lower loop, I will choose it counterclockwise. Counterclockwise, of course. This one here, it is upper loop. Okay, and it is clockwise. Okay, now the lower loop, I will write the lower loop counterclockwise. Okay, I apply Kirchhoff's second law. I have only one battery, which is E here, 12, okay? This is I1, which is 12. It agrees with the direction, or not agrees, I'm sorry. The direction I chose, it goes out of the positive. It goes out of the positive, which means it is positive 12, okay? I have this resistance. What current goes into it? It's actually I3. So it's going to be, and pay attention that I3, okay, agrees with the direction I chose. So it's going to be minus 6 I3. Okay, and also I have the internal resistance, okay, with the I1 going into the internal resistance, which agrees with the direction I chose. So it's going to be minus 2 I1 equals to 0. This equation is 3. Okay? Let me remind you, we are looking for I3. Notice here that I have 3 equations with 3 variables. 3 equations with 3 variables. Let me change the color. I'll take this one, okay? Now, from equation 2, let me go up a little bit here. I don't need the drawing anymore. From equation 2, we can write 6I2 equals 12 minus I1. This we call it 4. From equation 3, I can say that 6I3 equals to 12 minus, it's actually here 2I1, here minus 2I1. This is equation 5. We notice from equation 4 and 5, they have the same second side. It's 12 minus 2I1 and 12 minus 2I1, which means, this means that 6I2 equals 6I3. That means I2 equals I3. Okay? We can substitute this in equation 1. I can say that I1 equal 2. Instead of I2, I put I3 plus I3, which means I1 equals 2I3. I know it's a long question, but believe me, with practice, you will find it very, very simple. Okay? Now I got I1 equals 2I3. Now what do I do? Now I use this, let's call it 6. I will substitute 6 into 5. I will substitute 6 into 5. Okay. Now, We go back to 5, equation 5, 6I3 equals 12 minus 2 multiple I1. I1 is 2I3. So instead of I1, I put 2I3. Okay? This means, let's go up a little bit. Okay? 6I3 equals to 12 minus 4 I3. I take this to the other side, change the direction. I will have 10 I3, because 6 plus 4 is 10, equals 12, which means I3 is 12 by 10, which is 1.2 ampere. And this is the solution of the question. They said, find the reading of the ammeter, and we agreed. Reading of the ammeter is I3. I just found it. It's 1.2 ampere. So the answer is A. Okay? Again, as I promised you, I will make a video just to explain how to solve Kirchhoff's second law. Okay? Feel free to watch it many times just to understand any idea that there's a problem about. Anyway, have a good day. I'll see you later. See you. Bye-bye.